everyone. In this video we will learn about Venturi pressure in aviation refuelers. When fuel is pumped to an aircraft you want maximum flow, but pressure must be kept below 50 psi. Controlling of the fueling pressure is done by pressure control valves installed in the refueler, but this valves for its operation needs to monitor the nozzle pressure. But considering the structure and position of refueling hose and the nozzle, it is not feasible to install a pressure gauge at nozzle end. Let's analyze the problem in detail. When fuel starts moving from refueler tank to nozzle end, the pressure inside the pipeline starts increasing, but it decreases from tank to nozzle end due to frictional losses. It means that during fuel flow, pressure at point A is greater than pressure at point B. Similarly, at nozzle and C, pressure would be lesser than point B. Suppose the pressure at point A is 90 psi, then due to frictional losses, pressure at point B is 70 psi and at point C, that is, at nozzle end, is 50 psi. Now if we increase the flow rate, the pressure at all the 3 points would increase. This increment of pressure at nozzle end needs to be measured, so that pressure control system of the refueler can bring it down below 50 psi. Here the problem starts as we cannot install a pressure gauge at hose or nozzle. The next possible installation point is point B. But if we directly install a pressure gauge at point B, the pressure control system will start operating much before, because pressure at point B reaches 50 psi much before that at point C. To solve this problem, we need to install a Venturi between point B and hose reel. A Venturi has 3 sections: a converging inlet, uniform throat and a diverging outlet. When fluid flows through Venturi, the pressure at throat region decreases compared to inlet of Venturi, but it again reaches near to inlet pressure at outlet section. This happens because, as per Bernoulli theorem, pressure energy converts to velocity head at throat due to decrease in cross-section area. And again, with the increase in cross-section at outlet, pressure head of the fluid increases. So if we have a refueler where pressure drops to 30 psi from point B to nozzle end, we need to install a Venturi before reel hose in which pressure at throat drops to 30 points compared to inlet. Now pressure at the throat of Venturi is equal to that at nozzle, and we can install a pressure transmitter at throat of the Venturi to signal the pressure control valve. So we are basically measuring the pressure at Venturi throat, which is the simulated version of pressure at nozzle. That is why nozzle end pressure is also called Venturi pressure. Now if we change the hose length, the drop in pressure from point B to point C will change. Suppose it changed from 20 to 17 psi. As a result, Venturi throat will send pressure signal of 50 psi to pressure control system, although at this point nozzle pressure is 53 psi. To solve this, we need to compensate this decrease in pressure at nozzle end to the Venturi gauge by using a needle valve. Some fuel is passed from high pressure region point B to comparatively low pressure zone Venturi throat. As a result, pressure at Venturi throat raises to 53 psi. It is now tuned with nozzle end pressure. So every time the hose length or the nozzle is changed, the Venturi pressure needs to be tuned with nozzle pressure using the needle valve. If you have found the video helpful, please subscribe the channel and press the bell icon.